All right, we are live for Advent of Code 2024, day 5, starting in half an hour. At the end of my stream yesterday, I did do some refactor of day 3, and after I closed, I did further refactor. So just want to get this up here for anyone following along. I was happy with the refactor using regexes. I brain farted, and I was doing, I was using the regex and finding the first in, and just repeatedly finding that. Turns out that's already built in. I could do this. So I did that, and I took out the enum ADT I had for this do don't mul. It wasn't really necessary at that point. So a lot more concise, and I think in this state it's very readable. So I'm happy with that. For a warm-up day, I'm gonna go continue with 2018. And I think I was in problem 4 was very interesting. And I hadn't finished it yet. I finished part 1. So, as a recap, we're given this log of guards falling asleep and waking up. And the goal for part 1, let me pull this up here, was to find, oh, this is a lot of code. This is way too long. Is to find the sleepiest guard. I called it the most sleepy guard. I don't know why. But the one that sleeps most. And then figure out which minutes they're asleep. And whoever that is, find the minute that they're asleep most and multiply that by their ID. I don't know that a refactor will necessarily help me right now. Let's look at part 2. Put myself behind here. So, strategy 2. Of all guards, which is most frequently asleep on the same minute? Okay. So, in the example above, guard 99 spent 45 asleep more than any guard, or minute, 3 times in total. Okay. Which guard is most frequently asleep on the same minute? So for all guards, we take. Okay, formally, we are taking the sleepiest guard and finding the minute on which they are most often asleep. So we can already find the minute on which they are most often asleep. And then I guess we need to know the number of times that they are asleep in that minute. Okay. And then the ID of that card multiplied by the minute you chose. Okay. So I suspect that if this sounds really easy, given the code we already have, but I suspect that the problem here is that it's going to be less efficient. I mean, how many guards do we have? Let's see. All shifts by guard. Okay. Shifts by guard, that size. We have 23 guards. And how many shifts? 200 shifts. Yeah, okay. I think this is fine. Let's go for it. So we have guards by shift. We want for any guard instead of shifts. Let's see, sleepy shifts. This is the shifts of the sleepy guard. but we just want the shifts of any guard. Minute most asleep, given a list of shifts. Okay. And wow, okay, there's a big autocomplete here. Do we like this? Let's just get rid of that. So we can do this similarly to how we did just put next to this which minutes asleep. Okay, so shifts. We want the minutes to sleep for each pair within the shift. So we still do this thing. Very similar. In fact, we also still do the group map reduce. And instead of max by, oh, we just basically return that map. Okay. So shifts. Well, it's sleep. And I guess we still do a max by to find that minute. Oh, minute and account. Yeah, actually, we do exactly the same thing. So I guess, I mean, this should be a method. Uh, yeah, okay, so this is perplexing to me because this does seem like it's just part one. Okay, so now we just do this for all the guards. So guards or shifts by guard map. So we take ID and minutes most asleep. Sure. And then we want a max by count. And then once we get that, I can make this a max by option so I can just map on it. And we take ID times the minute. Yeah, okay. That's 2. Oh, so this can just be max by 2. What is this actually returning? This is returning a tuple. So what's the issue here? Found unit. Oh, because we're assigning. Okay, 516. I didn't write any new code. Answer's too low. I think I'm misunderstanding this. 516 too low. Hmm. Okay, okay. So let's read this again. Guard 99 spent minute 45 asleep more than any other guard in a minute. I really need to kind of restructure. This is, there's a lot of refactoring to do here. So this is the minutes that they are most asleep, and the minute and the count the number of times they were asleep during that minute, given a list of shifts, right? Um, Maybe we use our example and see if we at least get some correct answers. So do I have an example for this? Okay, day 04, 2020, 2018. All right. Okay, here we get an answer of 45, which is too high. But let's just take this part here. So we do this for all the guards. Um, what is this? Sleepiest minute? Okay, so sleepy minutes by guard. And let's take 90. Is there a guard number 90? Okay, let's see. 10 and 99. Oh, there's only two guards, number 10 and number 99. Okay, so let's try that. Okay, this says they were asleep during minute 24 twice. Okay, so when we're looking for the minute when they were most asleep, um, we were taking their list of shifts and what is this minutes of sleep? Yeah, basically getting a list of the minutes in which they were asleep for each pair of sleep wake events. Right, and once we have all of those, hmm. So we're doing that for all of their shifts. So this is across all of their shifts. I mean, what we took, oh, sleepy shifts is still, we should be using shifts that we pass in. That's what's going on. Okay, okay. This is why we should write things as methods. So that, yeah, why are you still getting 50 as an answer here? So we're getting the right thing for 99. You can see whatever this is for 10. Max by count should get us 33, and then 45 times 99. Oh wait, this is am I taking sleepy shifts? Oh wait, ends 2 is up here. I see. Okay. Yeah, we've got it. We've got it. So yeah, I didn't write any new code for this. Oh, is there a tie? No, it's just empty. Okay, this was working. Um, I'm taking max by. I guess we're using minutes most asleep. So some of these, right, some of these shifts don't have anything in it. So let's do this. If shifts is empty, I guess 0, 0 is fair. That shouldn't mess anything up. Okay, shifts by guard. No, not if shifts is empty. Like a certain shift might have no events in it. So it's not quite what we want. Shifts to events are grouped by 2. Let's just do an or else. Dot get do a max by option get or else 0, 0. That should do us. Guard 99 doesn't exist anymore. Our answer is 5705. Okay, yeah, fine. So I would like to do some cleanup here. Um, so we had this def. Minutes must asleep. And what's the other def we had? Which minutes asleep? I think for one, this which minutes asleep could just operate on a list of events. Yeah, rather than these 2 times. Should operate on a whole shift, actually. Yeah, let's make it operate on a shift. Okay. And basically this. Let me see, we had it here on the right. All right. And for each pair, we get this little sequence. And we turn it into a list. Minutes asleep. See, minutes asleep sounds like it's ambiguous. Is it the minutes that they were asleep or the number of minutes asleep? So we should rename that. Let's say rename minutes spent asleep. So we have a method which gives us the, well, it's still ambiguous. Total minutes spent asleep. Yeah. Total minutes sleep. And actually, this is even sort of unnecessary because if we just get all the minutes spent asleep, like this which minutes asleep, then the total minutes asleep is just the size of that list, right? Let's see if we can do it in terms of that. Well, we can rewrite that bit later. So we take the most sleepy guard, and then this thing here, minute most asleep. Let's call this the sleepiest minute. Sleepiest minute. And sleepiest guard. Sleepiest guard. I don't think we need that sleepy shift. Oh, I guess we do need that. And this val minute count can be which minutes asleep? Not quite sleepiest minute. Um, okay. And it adds one. So sleepiest minute of the sleepiest guard. Times the sleepiest guard. And that's just adds one there. Okay. Um, start and end. What is start here? Start is we're getting some weird errors. Let's go through them. Shift.events. Oh, let's just found iterator, acquired a list. Oh, okay. I guess we do like a to list here at the end. And the switch minutes asleep. Now applies to whole shift. So we can do shifts.flat map, which minutes asleep. Okay. And then this total minutes asleep doesn't need to exist anymore. Total minutes asleep can be defined in terms of which minutes asleep. And the sleepiest guard. Actually, all these vowels we're defining here. This is kind of part of the ANS one, so I'll put it down with ANS one. So total minutes of sleep is. Oh, good morning. Good morning. Yeah, every day I've just been using old puzzles as a warm up. Get me in the mood. Get my juices flowing. Okay. And now, since which minutes of sleep depends on, or total minutes of sleep depends on which minutes of sleep, I feel there's probably a factor in here. This puzzle I thought was kind of cool. I don't need this. Okay, well that works. I'm a little bit happier with the code. I think we call that good. You just need your coffee, and you're good to go. Hmm. I wish I could have a coffee right now, but it's midnight and I need to sleep after this. Hmm. Uh, Instead of coffee, I do little nicotine patches. Shorter half life. Let's see. Do I want to do more refactor this? I feel like the best way to refactor things sometimes is just to leave and come back to it, and then it becomes super obvious what needs to change. Like, for example, day 3. I refactored this yet again with so I switched to regexes, but now I remembered that you could do find all for the regexes, so I don't need to handle my own thing. And then I removed the little enum ADT I had going on, and it's much more concise. Um, and I know there are other tricks you could do. Someone talked about just doing a search and replace and removing everything inside a do and don't so that you can just use the same um, code from part one, which is clever. I thought that was a good way to do it. Eric Wastel, hey. Yes, yes, I feel ready. I was just going through old problems as a warm up. So I just did day 4 from 2018, which I thought was fun. Is the one with the guards and their sleep wake shifts. Whereabouts? Welcome back. You feeling ready? Ugh. Unscrew ups. Oh yeah, you're telling me about getting. Yeah. As much as I like to complain about reading comprehension, having that be part of the problem is fun. I appreciate that. It's an extra dimension. Coast to Apogee. Welcome. Oh yeah, good question. Any server problems after day 2? Um, does day 2 get removed from the points because of that, or was it not that bad? Oh, oh no. Like an intentional one? Okay. AWS blocked the DDoS almost immediately. Okay. Cool. Cool. Sounds like a good way to do it. 500. You're a beta tester. Oh, wow, really? A beta tester. That's cool. Hey, you want to tell me what to do today? Okay, do good. Sure. Good is hard. Bad is easy. I like to keep things easy. Let me make sure I'm set up. Oh, hey, there's my 2-minute alarm. Blue, is this you here, number 12? Use a computer. Yeah, computing capacity helps. Um, Especially when you brute force things. I wish I had a much bigger computer. There have been a couple problems though, where solving it by hand was faster. Um, Day 23 of 2021, it was a search problem of like all these amphipods going into different holes, and they had like different time cost to move around. And it was also small enough to do by hand, so I did it by hand. All right, good luck, Arrow Bounce. Good luck, Blue. Let's do this. Yeah, some pre-processing makes sense. Also, one of the day 24s where you had like machine code, that was kind of a lot of like by hand or like in head thing. And I like last year using all the ones where you had to generate a graph. Okay, problem 5. Print cube. Um, Interesting. So pairs of numbers with input. Let's just read the problem here. What do you get if you add up the middle page number from those correctly ordered updates? Uh, Middle page number, page ordering. We have to read more of this. Um, the sleigh launch safety manual won't print correctly. Okay. New pages for the safety manuals must be printed in a specific order. XY means if both page number X and Y are to be produced as part of an update, X must be printed before Y. Okay, so we make some graphs and dependency graph. X before Y. The ELF has for you both the page ordering rules and the pages to produce in each update. Oh, wait, so there's more to this. Uh-huh. Okay. So page order rules make a graph. Pages to produce. But you can't figure out whether each update has the pages in the right order. Okay, sure. Georgian rules, yada yada. 47 before 53. Not necessarily immediately, just before. There's a word for this kind of ordering of dependencies, and I forget what it's called. The second section specifies a page number of each update. What is an update? It means that the update consists of those page numbers. So for each of those pages, you have to print all of their dependencies, as long as you end up having those. To get the printer going as soon as possible, start by identifying which updates are already in the right order. Oh, okay. So some of these are ordered. And the example above, that's in the right order because, yeah. Okay. The actual list of page ordering rules is bigger. Again, determine which are already in correct order. So middle page number from those correctly ordered updates. Okay. So the first bit is called the page ordering rules. Uh, oh, you know what I want to do? Hold on, let me search something real quick. Okay, so I was wanting to use a source. Okay. And we're gonna have two parts to the input. So let's do this. We have page ordering rules and pages to reduce. Oh, that feeling. Yeah, 5 minutes to read. I'm just starting. Okay. Rules. So these rules, I guess what's called these raw. Um, let's just take a look at this. We don't need to do that. So I'm being silly. I don't need to be parsing with this granularity. I could just collect. So case. So there's a before and an after, right? B. Oh, sure. Yeah, before and an after. And we'll just do before.toInt, after.toInt. And then we need like a dependency graph. So this will be a map. And basically for every after, for every after we collect all the befores. So we take the page ordering rules. I don't think we quite group map. I think we first want to do map.swap. And then we do the group map. Yep, that's exactly what I want. Okay, so for example, graph, let's just see, 75. What needs to go before 75? Any of those. Okay, so pages to produce, map. Let's see. Oh, what do we do? So we have a line, and we're going to take a line that's split on a comma. Map those to int, to list. And I guess we can call this the updates. So the updates. And I'm just going to do this collect, because I don't know if we have like an empty line in there somewhere. Line, if line that contains a comma. And we could have just done that on the input itself. And we filter these updates. Updates.filter. Val correct order. So we have a list of pages. Maybe I didn't want to do it this way. So we have the dependencies. What do we do? So swap left is the after. Let's do page. Let's get the whole like prefix. So pages dot inits dot for all. So there is a page, and then before, and then this is true if before dot for all val dependencies. Dependencies contains. Okay, cool. And I guess if it's no, we just do true. Okay, so updates.filter correct order. Oh, wait. Yeah, we've already done that. So these are the correct order updates. Let's make this def pages list int and updates.filter correct order. Okay. And for each of those updates, we take the middle. Def middle page. So there's an odd number. So assert pages. Yeah, make sure it's odd. And then we'll take pages.size over 2. So we filter for correct order. Middle page, and then take this up. Okay, 57. That took too long. No. Okay, 57 is wrong. Okay, let's just try this on the example. See what we get there. 5. Okay. What answer do we get here? Wait, are we getting? Oh, yeah, it's actually. Key not found 97. Why is it even trying for a 97? Oh, hold up. I see. We need a default value for this map. With default value, and it's just an empty set. Yeah. Oh, okay. Well, let's see which updates are in the correct order. So updates, let's just make sure we're seeing this right. For each and we just print line that. And then let's filter for the correct order. It says none of those are in the correct order. Okay, let's test this. We know 47 should be before 53, right? So let's do 47, 53. And does 53 appear anywhere else? 53, 13. Okay. So let's see what's happening here. When we have a page and its dependencies. Oh, hold on. The first page, this is not before, this is the after bit. So why don't we reverse this? Pages.reverse. And instead of inits, we take tails, I guess. Okay. Okay, great. So for that, the answer shouldn't be 5. Let's see which one's our correct order. So 61, oh, which is the middle number. So we get pages size over 2. 143. Okay, there we go. 4905. All right, cool. How'd I do? 2700. All right. So for part 2, for each incorrectly ordered updates, use a page ordering rule to put the page numbers in the right order. So we just sort using the map. After taking only the incorrectly ordered updates. Okay. Filter not correct order. And then sort. We sort. The thing is, we don't really have. We have a partial ordering. So how can you conveniently use a partial ordering to sort? Map resort. So this becomes list event as well. Right now, just get the same thing back. Map, middle page, and then take the sum there. Okay, so this resort function. So we take pages. If we turned the partial order, can we turn it? Can't possibly turn that to full ordering. So I suppose these are carefully selected such that um, yeah, there has to be a singular correct answer, right? So we probably do have something that's sort of like a total ordering in this local scope. Let's just try this. Sort by. Um, no, we're gonna sort. We're gonna pass in the custom ordering. Sorted. Okay, so ordering. Can we pass in? Can we pass in a function? Sorted. Let's just make an ordering. Ordering. What constructors do we have for an ordering? A function from T to S. Now that uses, yeah, so ordering by uses a different ordering from less than. From less than could work. Maybe. Okay, so from less than is one less than the other. Um, we don't really need this. Basically, we can just say, so A is less than B if, let's see, A comes before B, rather, if B's dependencies, if B deps A. So we just do that. That's all we need. Okay, 6204. Easy, easy peasy. I wish I could have done that a bit faster, but I think I made some time. Yeah, I definitely made time on that one. Good delta. I'm happy with that. Okay. Hey. Okay, so this can just be rewritten as graph of B applied to A. Let's make it more legible. We're gonna rename graph. I didn't want to distract you, but I wanted to mention that I like the color scheme you're using. Ah, thank you. I've chosen this color scheme specifically for Advent of Code. Look, it has like the green, purple, and yellow. It matches. Yeah. Okay, so graph is not a good name. Um, this is dependencies. Whoops. So let's rename that. Dependencies. Updates, correct order, middle pages. I'm happy with that. What is this? We don't need this anymore. That's a test. Middle pages. Using more colors than Eric ever does. I have not seen Eric code. You mean like in his with how you sorted things? Nice, nice. Um, can I see that? Yeah, I think so. This wouldn't work in general, and the reason doing it this way is because I think it's a carefully selected list of pages, such that this forms a total ordering. So you don't need to make a graph of dependencies and check like transitive dependencies as you would otherwise. Because right, since this forms a partial ordering, if you gave it just an arbitrary set of pages, yeah, if you give it an arbitrary set of pages, then there could be multiple possible answers. So this only works with a specific set, I'm pretty sure. Eric doesn't use syntax styling, fun fact. Yeah, yeah, I have more colors on the website. Um, dependencies. Oh, right. Let's just do this. Okay, and this garbage here, you know what I could have just done? I could have just done my usual input get lines to list. I was doing some silly stuff. And then this can just be a collect. So we only do this on lines that run that way. So input.collect, sure. And then here we just do input.collect, line if contains comma. There we go. Okay, okay, great. I like this problem. This is very fun. Um, I'll commit that. Oh, hold up. And maybe now that we've done this, let's do day 5 of 2018. Well, people come in having finished theirs. So let's do day 4, 2018. Thank you, thank you. Well, have a good night. Thanks for stopping by. You got to use a lambda function with 2 arguments today. Nice. Hey, I'd like to see your code if you have it on GitHub or something. Oh, you know what? Before we do that, how did I do on the leaderboard here? So today I was slow for part one. I believe that. 6. Wait. No. 5. Okay, 7th for part one. And yeah, I had a good delta, so I was 5th for part two. That makes sense. There isn't even a 7th yet. 15 minutes plus another 5 minutes. I feel like I really could have done this in 10 minutes. Okay, day 5. Alchemical reduction. This sounds kind of familiar. Wasn't there one like this in 2021 or something? Oh, this is a group. Okay. Let's take a look at the input. So you just cancel things that are side by side. You scan the chemical bond position. Polymer. So we have a list of polymers. Oh, we haven't downloaded this one. 2018 day 5. Sure, yeah, I'd like to see a quick Git gist. Oh, wait. Polymers dot. Oh, there's only one polymer, so the input is a polymer. It's a single string. Okay, cool. Let's take a look at. Oh, hold on. It's requiring me to sign in. This is like a built-in browser. I think I've got to open this from Twitch. Okay. This is in Python. The rules for. Okay. And the hold. What exactly is hold? Okay, for I in hold. So you check each of them kind of pairwise. And then mark it as false potentially. So this constructs that's safe. And func tools comp to key. Nice. So lambda -1 if in rules, else 1 if BA is in rules. Okay. Yeah, that totally makes sense. Yeah, and rules being just a set of the pairs makes sense here too. You could look that up very quickly. So I transformed it into a map. I don't think I really needed to do that. Right, because you could just search for that pair. So I could save time by doing that. That's a good idea. Comp to key. I like that. You can pass in a key that way. Okay, cool, cool, cool. Thanks for sharing. Okay, so back to this day 5 from 2018. So there are smaller units react to adjacent of the same type and opposite polarity are destroyed. This is just a group like reducing. So this is like the inverse. And you just do this repeatedly. How many units remain after fully reacting to polymer? Okay. I think if the input was larger, turning it into a map dict would be more efficient. Yeah, waiting until you need a speed boost. That's a good principle to have. All right, arrow bounce. Good night. Good job today, and we'll see you around. Okay, this one seems easy. Let's just check the polymer dot size. Oh, we don't need this to be a list. Get lines like string, I guess. 50,000 operations. Or like potentially 25,000. And we gotta do this efficiently. So we could repeatedly search through the list. But like in the worst case scenario, you go through the entire list 50,000 times. 50,000 squared. We can do 50,000 squared operations. Yeah, we can totally make a set squared. Yeah, define a function called react. And we're not going to define it that way though. So polymer I guess we slide. And check for each pair if it's next to a capital. But now when we find a pair, how do we want to remove it? Maybe. Suppose we had a sliding window of size 3. Well, no. I'm trying to think about how to do this in a nice one-liner. We could just do a bunch of replace strings. There are only 26 different letters. Make 26 passes over on top of the 50,000 scores that we're doing. Maybe not. But you know what? Maybe. It's worth trying something stupid. C in A to Z. yield. Or we just do replace string. So polymer dot replace all. And yeah, exactly that. Just replace that with nothing. Oh, but we do that repeatedly. And I guess we could just keep doing that until there's nothing left to do. So we do a passive A through Z. So I'm gonna do kind of like a fold on this instead. Dot fold left. So we start with the starting polymer. And then we do that. And then the end result of that is what we keep. And then now we iterator.iterate. Start with our start polymer, and then react. And then now, take a sliding window of two of those, and we find the case. I don't like that autocomplete. Find the pair. And it's going to be collect first. Collect first. Or not. Yeah, and I'll just do like a dot get on there. Oh, wait. Collect first if a dot size equals b dot size, and we just return a. Okay, and then the size of that, val final polymer or reacted, fully reacted. Val and oh, fully reacted dot size. There we go. 11720. Okay, easy. No need to optimize. I almost went down rabbit hole optimizing that. Okay, it's preventing the polymer from collapsing as much as it should. Figure out which unit type is causing the most problems. Remove all instances of it. Fully react the polymer and measure its length. Okay. So let's take all the units. So again, we do A to Z. And then we remove from a polymer. So polymer not filter not too low or equals C. Yeah, exactly. And let's see, we take all the units, map, move from the original polymer. Let's make this a def or reacted polymer. So now we map to fully reacted. And what's the length of the shortest point? So we get yeah, map size dot min. And that's our ends too. It's the character. And it's slow. Okay, now we do need to optimize. Is there a way we can kind of tell in advance? Oh, 4956. Yeah, we just let run a few seconds. 4956. Okay. Okay, good enough. Um, 4956, and we'll just say warning slow. It was about 10 seconds, right? Okay. And I think that's enough having a code for me for today. Let's find someone else to raid. Your son is awake for his toy of the day. Nice, nice. Well, that's cool. Who's still on? Bad Cop. Let's see Bad Cop do this in Bash. This does sound kind of tricky in Bash. All right. Well, good luck finishing off later. And I hope your son is enjoying his toys. Yeah, thank you. Thank you. Have a nice day. And we'll see you all tomorrow. Actually, let me think. How would I approach this in Bash? Finding the middle. Okay, you check if a file contains that pair. Oh, so this is a case where you could check if the second contains the list, right? I'm still streaming, aren't I?